We're going to finish up Unit 1 or Chapter 1 with learning to solve problems systematically. We're going to learn something called dimensional analysis. So this is one of the things that chemistry students struggle with the most, I feel. They don't like to step back and work on a problem. They'd rather just take numbers in a problem and punch them into your calculator instead of systematically trying to figure out what's going on. So we're going to look at this approach, and hopefully it'll help you solve problems in the future. So first, where am I going? That's what you need to know. What do you already know? What kind of conversions can you use? What kind of equations do you have? What kind of information can you get from the periodic table? That's all in your what do I know. And then, how do you get there? How do you get from what you're given to what you need to get to? With dimensional analysis, we use something called the unit factor method in some of our conversions. The unit factor method just means that if I were to put one of the units with a number over the other one, it would reduce to 1. So 1 meter is equal to 1.094 yards. I could put 1 meter on the top and 1.094 yards on the bottom, or the vice versa, and it would equal the same thing. Same thing on down here. These are all what we call unit conversion factors, and we'll use those when we do dimensional analysis. So we have all kinds of equivalent statements. A lot of times on the either in an appendix or in the inside front cover or inside back cover of a chemistry textbook, you'll see those equivalent statements. Sometimes they're a multi-step process. And so when you do dimensional analysis, you need to make sure that you're also multiplying and dividing units so that you come out with the correct units. So first example, you want to order a bicycle with a 25.5-inch frame, but the size in the catalog are only given in centimeters. So what size should you order? So where are we going? We need to know how many centimeters a 25.5-inch frame is. What do we already know? We know the size needed is 25.5, and we know this conversion factor. We know that 2.54 centimeters equals 1 inch. So in this particular case, when we set this up, here's what we're given. We're going to start off with that and make sure we include units. Well, we want these units to cancel out, so we're going to use this unit factor. We could flip it and it would be the same. It would be the same conversion, same unit, but we need inches on the bottom, so the inches cancel out, and we need centimeters. So in this case, we would order a 64.8 centimeter bicycle tire. Second example problem here, a student has entered a 10-kilometer race. Most of us don't understand what kilometers are, so how long is that run in miles? So where are we going? We're going to convert kilometers to miles. What do we know? We know the run is 10 kilometers long, and how are we going to get there? So in this particular example, you can do several different things. You can find a direct conversion from kilometers to miles, or you can use some intermediate conversions. And so generally this is one that's given in a textbook a lot of times. We have kilometers, which we want to change to miles. So we can go from kilometers to meters, because that's a metric conversion. We know what that is. Meters to yards, that's up here in this. And then we also know, because we're used to the English system of units, we normally know how many yards are in a mile. We might have to look that one up too. So here are our equivalent statements, and we're going to put those in several different steps. So when we go from kilometers to meters, here's what we're given. This is what we were given in the problem. This is our conversion factor. When you do metric conversions, sometimes it's hard for students to know. They'll know what number. For example, they'll know there are 1,000. The 1,000 is the number they use, and the units are meters and kilometers, but they won't always know where the 1,000 goes and where the 1 goes. My rule of thumb is the bigger number goes with the smaller unit. So since meters are smaller, the 1,000 goes there, and the 1 goes with the kilometers because they're a bigger unit. So once we convert that, and notice we use 3 significant figures here. We had 3 there, although that's not as important in this particular problem since this is a mid-step. So now we're going to go from meters to yards. Here's our conversion from meters to yards. Set that up. We come up with 1.094 times 10 to the 4th yards. We should only have 3 significant figures in the result, but right now we're using all the numbers we have, and so we're going to leave those numbers until we get to the end. Now we go from yards to miles. This is our conversion factor from yards to miles, and in this particular case, again, even though it's not a direct multiple of 10, like 10, 100, or 1,000, the bigger number goes with the smaller unit because yards are smaller than miles. And so we end up with 6.216 miles. And that, since we need 2 significant figures, we're going to round that to 6.22 miles. So 10.0 kilometers is the same thing as 6.22 miles. Now, this is normally what I do. I would normally combine the steps instead of doing them stepwise. And so we start with 10 kilometers, our conversion to meters, our conversion to yards, and then our conversion to miles. And we cancel out units as we go along. And if you do set it up this way, what you want to do is you want to take all the numbers on the top times each other. So 10 times 1,000 times 1.094 times 1. And then you're going to divide that by all the numbers on the bottom times each other. And you'll want to, if you want to do this one step in your calculator, you're going to want to get in the habit of taking everything on the top times each other. 10 times 1,000 times 1.094 times 1 divided by, and then open a set of parentheses and take 1 times 1760, close your parentheses, because order of operations generally will mess that up. A third example problem. In this case, we have a unit that has multiple parts. So Japanese cars advertise as having a gas mileage of 15 kilometers per liter. Does it have good gas mileage? We don't know because we're not used to using those units. We need to convert it to miles per gallon, so it's something that we can understand. So where are we going? We're going to convert 15 kilometers per liter to miles per gallon. What do we know? We know what the gas mileage is in kilometers per liter. And so how do we get there? We're going to use several different conversion factors. Now notice on this particular problem, the very first step, there's already something on the bottom, because if you have 15 kilometers per liter, that means that for every 1 liter, you get 15 kilometers. And so generally when I do a problem like this, I start off with what's on top and cancel that out. So what I want to get to is miles. So I'm ignoring the liters for now. Going to work through canceling out, getting to miles, and then at the next step I'm going to work on this. Now notice liters is on the bottom here, so I need to have it on the top here, and then I end up with miles on the top and gallons on the bottom. Again, you in your calculator take everything on the top times each other, divided by, open parentheses, everything on the bottom times each other, close parentheses, and you'll get 35 miles per gallon. And notice 2 significant figures, because in our problem we were given 2 significant figures. Okay, well that completes Unit 1 or Chapter 1, and we will look forward to seeing you in Chapter 2.